Okay, 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 okay. It looks like we can now continue with other business of the day. So let's do two more examples. I think it's going to be two of them, where we talk about rationalizing the denominators. That's exactly what we are going to do. So the principle of rationalizing the denominators is just to remove the surds in the denominator. That's exactly what we are going to be doing. So very much important that you know there is something called a numerator. If you don't, oh, say, and then maybe let me be practical and say we have what we call a denominator. Yes, these are the things that we are having, the numerator and the denominator. So the numerator is the one at the top and then the denominator is the one at the bottom. Okay, then it's fine. So when I say we rationalize the denominator, so it's like, okay, we don't want to have a square root at the bottom. This one, we don't want to have it. So the only way to not have it, it is to rationalize the denominator. We remove it from having a square root to just being whatever that will be there. It is a number that will expect it to be there. Let's say an example there. It's not complicated, trust me on that one. If you are having 6 over square root of 3, can you see this problem? We do not want to have a square root at the bottom. But before we can do much, would you agree with me when I say anything multiplied by 1, it is that same thing. It doesn't change. Please do punch it on your calculator and you will realize that indeed anything being multiplied by 1, it remains as it is. Okay, if that is the case, would you agree with me if I say, now that 6 over square root of 3, we will multiply it by 1, but a very special one. The special one is that we will multiply it by a fraction of exactly that. Why exactly that? Because we want to remove it. So which means you'll multiply it by square root of 3 over square root of 3. Square root of 3 over square root of 3 is 1 most, because it cancels. So can you now see, we haven't changed anything. We continue to multiply it by 1, which means this multiplies that and that multiplies that. That's it in short, honorable member. So that means you are having the 6 multiplying that square root of 3, and remember what the law says. You are having that 3 that multiplies by that. So you end up having 6 square root of 3, which is being, what is that times that? Definitely that is 9. What is square root of 9 is 3. So that means you end up having that. It doesn't end there because 3 goes into 6. How many times? 2 times. Then you have 2 square root of 3. And that is the end of it. So what you've done, it is just to rationalize the denominator. That's what you have just done, a honorable member or the member who is honorable. Yes, that's what you have just done in short. I would like to believe that what I've just done makes sense. So it doesn't matter, even if you have what, I'm trying to think of something, I'm trying to think of something. Let's say you have negative 3 over square root of 2. Yes. Should I exaggerate it and maybe say 2 there? Yes, okay. Let me just take a second. Okay, again, I will still multiply it by that. This question I just came up with it. It's not like it's on my notes. I'll multiply it by 1, but a special 1 in this case. So that means we have that negative, what is it? Negative 3 over that 2 square root of that. Can I not multiply it by that square root of 2 over square root of 2? I've just multiplied it by 1. Remember, the goal is for me to remove that square root. So you end up having this multiplying with that. You obviously have invisible 1 there. Same there. And then it's like you have your negative 3 square root of 2 over, here you will definitely have 2 multiplying that 2, you end up having negative 3 square root of 2 over, definitely have 2 that will multiply. This times this, it's 4. Square root of 4 is 2. So that means you end up having that, whereby you can therefore say this is now what you that times that is 4. Then this should be the end of it, honorable member. So can you see, you've just rationalized the denominator, which means you don't want to have a square root as the denominator. Let's look at something which may be considered to be complicated or difficult. In a situation where you are having 5, let's say now it's over 4 minus square root of 3. What an interesting problem that you are having there. What an interesting problem that you are having over there. What an interesting this is interesting. Definitely, this is interesting. Let's see. Just trying to think about it, honorable member. I'm just trying to think about it. But what I know is that, okay, I will just have to multiply this thing by 1. So you are having that and then square root of 3 there. You're going to multiply it by 1. So this one, because it's 2 terms, you can't just multiply by this alone. Otherwise, it's going to be something else. Rather, multiply it by exactly that denominator of 4 minus square root of 3. That means you will therefore multiply it by that same thing. But this time around, you might need to be smart. You might need to be very smart, honorable member. How so? Multiply it by 4. Instead of a minus, let's make it a plus there. Why a plus, you will find out soon. Whatever that you are having there as the numerator, you must also have exactly the same thing, because this divided by that, it takes us back to 1. So you haven't changed anything. But the reason why you had to multiply by the 1 that has a, what is it? A plus. It's because you wanted to have the difference between 2 squares. Something of that nature where, let's look at it. Obviously, this multiplies that and that multiplies that. So that means you're having 5, which is multiplying 4, that you plus it by square root of that divided by this thing. Is it not the same as the difference between 2 squares? You will see it as I do my next step. Obviously, you can still say that by that by that. We get sorted with that is 20, that you plus it by 5 square root of 3, the whole of this being divided by. This thing is the same as you having a, what is it? What is it? A 4, maybe let me put it inside the brackets. I will explain that part. It's the same as you having 4 squared minus, and then you again having that. It's exactly the same thing. Because if you remember, with regards to the difference between two squares, if you are having, let's say, 3, and then it could be a plus here, let's say x. As long as you have that same thing, but the sign is different here, we know that the reverse of this is because it was 3 squared, nay, a minus x squared, the difference between two squares, whereby the reverse of this again, it is actually 3 squared is the same as 9 minus x squared. So in an exam, you may be given that and they say factorize. You will do that and thereafter you will do that because it's the difference between two squares. So it's like here, we are doing the same principle in reverse because we can see that we manipulated it such that it is exactly the same thing except the signs are different. And we know that in reverse is the difference between two squares, which means as your next step, you can therefore say, what is this squared? Definitely that is 16. And then minus 2 of exactly the same thing. I'm sure you know by now how that works. Otherwise, you can just know that a squared removes the square root. How so? Because if you remember, we have invisible 2 there. So this thing is the same as 3 to the exponent of that invisible 1 over 2, and that outside, where that cancels with that, you end up having 3 there. And then you will therefore end up having that and that, whereby we do, what is that minus that? Is it 13? Yes, it should be 13. Yes, it should be 13. And that is the end of it. As you remember that you are expected to deal with these things decisively without the use of a calculator. Very, very much important on that one, honorable member. So, yes, I think that should be the end of it. That should be the end of it. Yes, based on what I'm thinking, I think this should be the end of it, honorable member. Okay, it is for that reason why I will